December 1941. The outskirts of Moscow. Temperature 40 degrees below zero. Soviet artilleryman Sergeant Mikhail Kuznetsov crouched behind a hastily dug gun pit, watching German panzers materialize through the swirling snow. His 76.2 Mio divisional gun, a pre-war design that weighed nearly 3,000 pounds, had taken his entire crew 6 hours to manhandle into position through snowdrifts. Now, as the panzers advanced, Kuznetsov understood the bitter mathematics of Soviet artillery doctrine. His gun could kill the German tanks, but moving it required horses that were starving, or trucks that had frozen solid, or men who were already exhausted beyond endurance. 300 miles to the east, in a design bureau at Artillery Factory No. 92 in Gorky, a 35-year-old engineer named Vasily Grabin was solving an equation that would change the course of the war. How do you create an artillery piece that combines the hitting power of a divisional gun with the mobility of an anti-tank weapon, that can be mass-produced by workers with minimal training, that uses half the strategic materials of existing designs, and that can be manufactured without official approval from a bureaucracy that might reject it? The answer would become the Zis-3, the most produced artillery piece in history. Over 103,000 units built between 1941 and 1945. A gun so effective that German forces designated captured examples as the 7.62 Simplified FK-8ER and used them against their former owners. A weapon that would fire over 1.5 billion rounds during the war, more ammunition than some entire armies possessed. But the story of the Zis-3 is not primarily about ballistics or metallurgy. It's about a man who understood that in total war, the weapon that can be built fastest and cheapest often matters more than the weapon that performs best on paper. It's about engineers who designed for the assembly line before they designed for the battlefield. And it's about a production system that could turn out a complete artillery piece faster than German factories could manufacture the barrel alone. Vasily Grabin was not a typical Soviet weapons designer. Born in 1900 to a peasant family, he had studied engineering through night courses while working in factories. He understood production from the factory floor, not from theoretical manuals. By 1941, he was chief designer at Factory 92, the Soviet Union's primary artillery plant, where he had already designed the F-22 divisional gun and the USV anti-tank gun. Both were effective weapons. Both were also expensive, complex, and slow to manufacture. The German invasion on June 22, 1941 revealed the fatal flaw in Soviet artillery planning. The Red Army possessed excellent guns on paper. In practice, those guns were being overrun faster than factories could replace them. In the first month of Barbarossa, Soviet forces lost over 20,000 artillery pieces. Factory 92 was producing perhaps 1,000 guns monthly. The mathematics were apocalyptic. Grabin understood immediately that the Soviet Union needed a gun that could be produced not at peacetime standards but at crisis standards. A gun designed around what Soviet industry could actually manufacture in 1941, not what artillery officers wished they could have. He gathered his design team in July 1941 with a challenge that seemed impossible. Combine the hitting power of our 76mm divisional gun with the weight and mobility of our 50mm anti-tank gun. Make it simpler to build than either. Make it cheaper. Make it better. And do it in 3 months. His team thought he was insane. The laws of physics don't change because Germany invaded, one engineer protested. We cannot make a 76-meter gun light enough for anti-tank work without sacrificing range or penetration. Grabin's response revealed his understanding of the crisis. We're not trying to make the perfect gun. We're trying to make the gun that will exist in enough numbers to matter. Physics is negotiable. Production capacity is not. The design process that followed violated every principle of Soviet weapons development. Normally, a new artillery piece required years of development, mountains of paperwork, endless committee approvals, and testing protocols that could stretch across seasons. Grabin had none of that time. Instead, he did something extraordinary. He began designing the Zis-3 in secret, without official authorization, using his own resources and hiding the project from Soviet bureaucracy. This was not simply bold. It was potentially suicidal. Stalin's purges had killed thousands for far less serious deviations from procedure. Grabin was risking not just his career but his life on the conviction that he understood what the Red Army needed better than the committees and commissars who officially controlled weapons development. His decision would either save the Soviet artillery arm or get him shot. The design philosophy behind the Zis-3 represented a complete rethinking of artillery engineering. Traditional gun design started with ballistics. What projectile, what velocity, what range, what penetration. Then engineers worked backward to create a weapon that could deliver those specifications. Grabin reversed the process. He started with production. What could Soviet factories actually build quickly and cheaply with materials that would remain available even under wartime shortages? The barrel became the foundation of his design revolution. Traditional artillery barrels were forged from solid steel billets, then machined to precise tolerances in a process that required skilled workers and specialized tools. A single barrel might take 40 hours of machine time. Grabin's team developed a barrel that used a thin-walled tube reinforced at key stress points. This used 60% less steel and could be produced in 12 hours by workers with minimal training. Artillery officers would later claim the design was structurally unsound. Over 100,000 examples would prove them wrong. The breech mechanism was simplified to just 38 parts, down from over 60 in comparable guns. Each part was designed for ease of manufacture, with tolerances loose enough that components could be made on standard lathes without specialized tooling. The firing mechanism used a simple striker system that a village blacksmith could understand and repair. Every component was designed around a single question: can this be manufactured by a factory worker who learned the job yesterday? The carriage, the wheeled structure that supported the gun, received similar treatment. Previous designs used cast steel components that required specialized foundries and long cooling times. Grabin specified welded steel plate construction that could be fabricated in any workshop with an arc welder. The wheels were simplified to use automotive-style bearings that could be sourced from truck production. Even the gun shield, the protective armor that protected the crew, was redesigned as flat plates that could be cut from sheet steel rather than curved components requiring expensive dies. The result was a gun that weighed 1,116 kilograms, less than half the weight of the divisional guns it would replace. It could be manhandled by its crew of 6 men. It could be towed by virtually any vehicle or even by horses. It could be brought into action in under 2 minutes. It could be manufactured using 1/3 the machine time and half the materials of existing designs, and it fired the same 76.2mm ammunition as the divisional guns it replaced, ensuring logistics compatibility. The ballistic performance was remarkable given the weight savings, muzzle velocity of 680 meters per second with armor-piercing shot, maximum range of 13.2 kilometers with high explosive shells, armor penetration of 70 mm at 500 meters, enough to defeat any German tank in service in 1941. Rate of fire up to 25 rounds per minute with a trained crew. These specifications matched or exceeded the heavier, more expensive guns the Zis-3 was designed to replace. By October 1941, Grabin had a working prototype. He had also committed what could be considered treason under Soviet law. He had diverted factory resources to an unauthorized project. He had assembled components without proper documentation. He had conducted testing without official observers, and he had done all of this while Factory 92 was supposed to be operating at maximum capacity producing authorized weapons. If the gun failed, or if Soviet authorities discovered the unauthorized project before it succeeded, Grabin would face a firing squad. He arranged a demonstration for November 1941, inviting Soviet Artillery Command to witness testing of what he described as an improved divisional gun. The demonstration nearly became his execution. When officers arrived and saw the lightweight gun Grabin was proposing as a replacement for standard divisional artillery, their reaction was immediate and hostile. "This is a toy," one general declared. "You've built an anti-tank gun and called it a divisional piece. It will never withstand sustained fire. The barrel will warp, the carriage will collapse. This is sabotage disguised as innovation." Grabin's response was to conduct a firing demonstration that violated every safety protocol in Soviet artillery testing. He ordered his gun crew to fire sustained sequences at maximum rate. The Zis-3 hammered out shells at a pace that should have destroyed it according to conventional engineering wisdom. 25 rounds per minute, 50 rounds, 100, 200. The barrel remained true. The carriage held firm. The gun crew, working smoothly with the simplified mechanisms, maintained their rhythm without fatigue. Then Grabin demonstrated the mobility that would become the Zis-3's signature advantage. His crew limbered the gun, moved it 200 meters, unlimbered it, and brought it into action in 90 seconds. They repeated the process, 80 seconds, again, 75 seconds. The watching officers, accustomed to divisional guns that required 10 minutes to reposition, watched in stunned silence as a weapon with divisional gun firepower danced across the landscape like an anti-tank gun. The final demonstration was penetration. Grabin had acquired a captured German Panzer III, the main German medium tank, in 1941. He had it positioned at 500 metres. The first armour-piercing shot from the Zis-3 punched through the frontal armour and exited through the rear plate. A second target, positioned at 1,000 metres, received similar treatment. The lightweight gun that artillery officers had dismissed as inadequate was killing German tanks at ranges where the tanks couldn't effectively return fire. Marshal Nikolai Voronov, chief of Soviet artillery, watched the demonstration with an expression that shifted from skepticism to astonishment to something approaching fear. Not fear of the weapon, but fear of how close the Soviet Union had come to missing it. He pulled Grabin aside after the demonstration. "How soon can you begin production?" Immediately, Grabin responded. "I've already prepared the tooling and production documentation." Voronov stared at him. "You built production tooling for an unauthorized weapon?" Grabin met his gaze. "I built it for the gun our army needs. Whether it was authorized seemed less important than whether it would exist." There was a long silence. Then Voronov smiled, a rare expression for the usually stern artillery chief. "You're either the smartest designer in the Soviet Union, or the luckiest. Possibly both. Full authorization granted. Begin production immediately. And Comrade Grabin, next time you decide to secretly develop a weapon system, perhaps inform someone in authority. I'll put you in contact with Comrade Stalin. Explain your unauthorized activities to him directly. He values initiative, though he expresses it in interesting ways." The meeting with Stalin, which took place in December 1941 while German forces were literally visible from Moscow's outskirts, could have ended with Grabin in a gulag. Instead, it ended with unlimited priority for Zis-3 production. Stalin, a dictator who had thousands shot for far less serious deviations from protocol, listened to Grabin's explanation of why he had developed an unauthorized weapon. Then he asked a single question. "How many can you produce per month?" 3,000 immediately, Grabin responded. 5,000 within 6 months if given priority for materials and labour. Stalin turned to Voronov. "Make it happen. This designer understands what matters. Not committees, not protocols, not theories. Production. Give him whatever he needs." The Zis-3 entered production in February 1942. What followed was one of the most remarkable manufacturing achievements of the war. Factory 92 in Gorky became the primary production site, but Grabin's simplified design meant other factories could tool up rapidly. By June 1942, 8 factories were producing Zis-3s. By December 1942, that number had reached 15. Many of these factories had never built artillery before. Some had been tractor plants, others had made industrial machinery. The Zis-3's design was so straightforward that factories could begin production within weeks of receiving specifications. The production line at Factory 92 was a marvel of simplified manufacturing. Components moved along conveyors where workers, many of them women and teenagers, performed simple, repetitive tasks. One station welded carriage plates, the next attached the trails, the long arms that extended behind the gun, the next installed the breech mechanism, the next attached the barrel. The entire assembly process, from raw materials to completed gun ready for testing, took 8 hours. Compare this to German artillery production, where equivalent guns like the 7.5 Pak 40 required over 150 hours of manufacturing time and could only be produced in specialized facilities by skilled workers, or to American production, where the excellent 76mm M1 gun required similar hours and skilled labor. The Soviets had created a weapon that could be manufactured faster than their enemies could destroy them. The simplified design also meant quality control became easier. With fewer parts and looser tolerances, there were fewer points of failure. Guns came off the production line ready for combat without extensive testing. If a gun failed in the field, which happened rarely given the overbuilt construction, replacement was simple. Throw the broken gun away and requisition another. With production rates exceeding 3,000 per month by late 1942, individual guns were nearly disposable. The ammunition production was equally impressive. The 76.2mm round had been standardized across multiple Soviet weapon systems, meaning ammunition factories could supply divisional guns, tank guns, and the Zis-3 from the same production lines. The standard high-explosive round, the OF-350, weighed 6.2 kilograms and contained 760 grams of TNT. The armor-piercing round, the BR-350A, weighed 6.5 kilograms and could penetrate 70mm of armor at 500 meters or 61mm at 1,000 meters. But the true innovation in Soviet ammunition production was volume. Ammunition factories operated 24 hours daily in 3 shifts. Workers, many of them women, assembled shells with the same simplified processes Grabin had applied to gun design. By 1943, Soviet factories were producing over 100 million artillery shells annually, more than Germany and Britain combined. Each Zis-3 in the field could expect to fire thousands of rounds during its service life, and there was always more ammunition available. The gun's first major combat test came during the Battle of Stalingrad in late 1942. The 13th Guards Rifle Division received 36 Zis-3s in September, just as German forces were pushing into the city. Lieutenant Anatoly Chekhov, commanding a 4-gun battery, positioned his Zis-3s in the rubble of a destroyed factory. The lightweight guns could be manhandled into positions impossible for heavier artillery. One gun was placed on the second floor of a partially collapsed building, another was hidden in a basement with a firing lane through a knocked-out wall. On November 11, 1942, German forces attempted to break through Chekhov's sector using a combined force of Panzer IIIs, Panzer IIIs, and supporting infantry. The Zis-3s opened fire at 800 meters. The first volley destroyed 2 Panzer IIIs, the armor-piercing rounds punching through frontal armor like paper. The Germans, surprised by artillery fire from multiple levels and unexpected positions, attempted to suppress the guns with tank fire. The Zis-3's low silhouette and small size made targeting difficult. The crews, working with the simplified mechanisms, maintained a rate of fire that stunned the German tankers. In 15 minutes of combat, Chekhov's 4 guns destroyed 9 German tanks and forced the remainder to withdraw. German after-action reports noted the appearance of a new Soviet gun, smaller and more mobile than previous designs, with excellent penetration characteristics. The lightweight artillery piece that could be positioned anywhere and moved rapidly was creating tactical problems German forces had no ready answer for. The Battle of Kursk in July 1943 would demonstrate the Zis-3's capabilities at operational scale. The Soviets, knowing the German offensive was coming, had months to prepare defences. They created defensive belts with extraordinary density of anti-tank weapons. Zis-3s were positioned in depth, often in groups of 6 to 8 guns covering key approach routes. The lightweight design allowed Soviet forces to create hidden gun positions that could be revealed suddenly when German armour approached. On July 5, 1943, German forces launched their offensive into prepared Soviet defences. The 3rd Panzer Division, attacking toward Poniri, encountered what their reports described as anti-tank gun walls, positions where Soviet guns opened fire simultaneously from multiple directions, creating crossfires that channeled German armour into kill zones. The Zis-3's rate of fire and accuracy proved devastating. Lieutenant Hans Becker, commanding a Panzer IV in the 6th Panzer Regiment, survived the first day at Kursk and later described the experience in a letter captured when he was killed 2 weeks later. The Russian guns were everywhere. We saw muzzle flashes from positions we had observed and found empty. They moved their guns during the night, repositioning constantly. Our maps showing anti-tank positions were worthless by dawn. When we advanced, the guns opened fire at ranges where we could barely see them. Our tanks were hit from front, flanks, sometimes from behind as guns we had bypassed revealed themselves. The Russians didn't have better tanks than us. They had more guns than we had tanks, and their crews knew their business. The statistics from Kursk are staggering. Soviet forces deployed over 6,000 anti-tank guns in the defensive belts, of which approximately 3,500 were Zis-3s. In the first week of combat, these guns claimed over 1,200 German tanks and assault guns destroyed or disabled. The Zis-3's combination of hitting power, rate of fire and ease of concealment made it the most effective anti-tank weapon at Kursk. German intelligence, analysing captured Zis-3s, was impressed by the design philosophy. A report dated August 1943 noted the weapon represents a fundamentally different approach to artillery design. Where German engineering prioritizes performance and precision, Soviet design prioritizes manufacturability and adequacy. The result is a gun that is good enough in all respects and superior in the category that matters most in total war. It exists in enormous numbers. The report concluded with a recommendation that was never implemented due to Germany's industrial limitations. German artillery development should adopt Soviet production philosophies. Our technically superior weapons mean nothing if we cannot build them in sufficient quantity. The Zis-3's versatility extended beyond anti-tank work. The high explosive round made it effective against infantry, fortifications and soft targets. Artillery officers discovered the gun could be used for direct fire support, indirect fire missions, and opportunistic anti-tank defense with equal effectiveness. A single Zis-3 battery could support infantry attacks, conduct counter-battery fire, and destroy German armour as tactical situations required. This versatility was possible because of Grabin's insistence on using the standard 76.2 meters divisional gun ammunition. Soviet logistics could supply Zis-3 units from the same ammunition stocks that fed divisional artillery and tank guns. There was no special Zis-3 ammunition to manufacture, transport or stockpile. Any Soviet unit with 76.2 mm shells could supply any gun that fired them. This logistics integration, often overlooked, was as important as the gun's ballistic performance. By late 1943, Soviet rifle divisions were receiving standardized artillery allotments that included 36 to 48 Zis-3s per division. Tank and mechanized corps had additional Zis-3 units for anti-tank defense. Artillery reserve included hundreds of guns that could be deployed to critical sectors. The Red Army had solved its artillery shortage through a weapon that could be produced faster than it could be destroyed. The production numbers tell an extraordinary story. In 1942, Soviet industry produced approximately 15,000 Zis-3s. In 1943, production exceeded 40,000 units. 1944 saw over 30,000 produced despite increasing allocation of production capacity to other weapons. By war's end, over 103,000 Zis-3s had been manufactured, more than any other artillery piece in history. For comparison, Germany produced approximately 23,000 Pat-40 anti-tank guns during the entire war. America produced roughly 15,000 M1 70mm guns, and Britain produced about 10,000 6-pounder anti-tank guns. The Soviet production achievement becomes even more remarkable considering the context. Factories were operating under constant threat of air attack. Workers were malnourished, overworked and often untrained. Raw materials were in perpetual shortage. Yet production not only continued but accelerated. This was possible only because Grabin had designed a gun that could be built under crisis conditions by workers operating at the edge of physical endurance. German forces capturing Zis-3s in combat quickly recognized their quality. The Wehrmacht officially designated captured guns as 7.62 cm FK 280s and issued them to German units. This was not merely opportunistic use of captured equipment. German armories reconditioned captured Zis-3s, manufactured ammunition for them, and intentionally deployed them in defensive positions. German after-action reports from 1944 frequently mention the effectiveness of captured Soviet guns, noting their reliability and ease of maintenance. SS Hauptsturmführer Ernst Bachmann, a tank ace who survived the war, encountered German-operated Zis-3s during fighting in Hungary in 1945. In his memoirs, he wrote, "Our own forces were using Russian guns against us. The confusion during one engagement was extreme. We took fire from what we thought were captured Russian positions, only to discover our own infantry had positioned Soviet guns there. The Russian design was so simple that our crews could operate them with minimal training. This would have been impossible with Russian tanks or aircraft, but their guns were straightforward and effective. The simplicity extended to maintenance." The Zis-3 could be serviced in the field with basic tools. The limited number of parts meant repairs usually involved replacing a broken component rather than complex adjustments. Soviet maintenance manuals for the Zis-3 were notably brief, often just 20 pages including illustrations. Compare this to German maintenance documentation for the Par-40, which ran to over 100 pages of detailed technical instructions. This maintenance simplicity mattered enormously in Soviet service. Red Army maintenance units often lacked tools, spare parts, or trained technicians. The Zis-3's robust construction meant it could function with minimal maintenance. When repairs were necessary, they could be performed by unit armourers without specialised training. This kept guns in service that would have been deadlined awaiting depot-level maintenance in other armies. The gun's effectiveness against German armour evolved as German tank designs improved. The Panther tank, introduced in 1943, had frontal armour up to 80mm thick, beyond the Zis-3's penetration capability at normal combat ranges. The Tiger I, with 100mm frontal armour, was essentially immune to frontal Zis-3 fire. Soviet gunners adapted with tactics rather than new weapons. Lieutenant Pyotr Gavrilov, commanding a Zis-3 battery in Ukraine in 1944, developed tactics specifically for heavy German tanks. The frontal armour on Panthers and Tigers was indeed too thick for our guns at normal ranges, he explained in a 1975 interview. So we didn't shoot at the front. We positioned our guns to catch the German tanks from the flanks or rear. The side armour on a Panther was only 50mm, well within our penetration envelope. We used the first gun in a battery as bait, firing from a position the Germans could identify. While they focused on that gun, 3 or 4 additional Zis-3s would engage from concealed positions, targeting the sides and rear. This required coordination and courage from the bait crew, but it worked. Soviet anti-tank tactics evolved to incorporate the Zis-3's strengths while compensating for its limitations against heavier armour. Guns were deployed in depth, with forward positions intended to force German tanks to button up and slow down, while deeper positions engaged from superior angles. The high rate of fire meant even glancing hits could damage optics, tracks, or external equipment, degrading German combat effectiveness without achieving kills. The Battle of Königsberg in April 1945 demonstrated Zis-3 capabilities in urban warfare. Soviet forces attacking the fortified city used Zis-3s in direct fire roles, targeting German strongpoints, fortifications, and buildings. The gun's lightweight construction meant it could be manhandled into buildings, positioned on upper floors, and even hoisted to rooftops to achieve direct fire angles that heavier artillery couldn't match. Major Ivan Sokolov, commanding an artillery battalion during the Königsberg assault, described the Zis-3's utility in urban combat. We put guns where artillery had no business being. Third-floor apartments with firing lanes down streets, basements with exit tunnels for crew escape after firing. We even positioned one gun in a church bell tower, using it for anti-tank overwatch. The Germans couldn't comprehend artillery in these positions. Their doctrine said artillery belongs in gun pits behind the lines. Our doctrine said artillery belongs wherever it can kill Germans. The Zis-3 made that possible, because 6 men could move it anywhere. The final Soviet offensive into Germany in 1945 saw Zis-3s used increasingly for infantry support and fortification destruction. With German armour largely destroyed and fuel shortages limiting panzer operations, anti-tank work became secondary to supporting the infantry advance. The high explosive round, containing nearly a kilogram of TNT, proved effective against buildings, bunkers, and prepared defences. By war's end, the Zis-3 had fired an estimated 1.5 billion rounds in Soviet service. This figure, while impossible to verify precisely, comes from Soviet logistics records tracking ammunition production and distribution. If accurate, it means the average Zis-3 fired approximately 15,000 rounds during its service life. For context, many American artillery pieces in Europe fired fewer than 500 rounds total during the war. The human cost of Zis-3 operations was substantial. Soviet gun crews suffered heavy casualties, particularly in the war's early years when German tactical superiority and air power inflicted terrible losses. A Zis-3 battery that entered combat with 36 men might lose half its strength in a major engagement. But the lightweight gun meant replacement crews could be trained quickly, and the simplified mechanisms meant even inexperienced crews could operate effectively. Sergeant Dmitry Lavrinenko, who served with a Zis-3 battery from Kursk through Berlin, survived the war and in a 1980s interview described the crew experience. We lost men constantly. New faces appeared weekly, sometimes daily during heavy fighting. The gun itself was our constant. Same Zis-3, same serial number, same worn paint. We painted kill rings on the barrel, one for each tank destroyed. By Berlin, we had 23 rings. How many of those kills were mine personally, I couldn't say. In combat, everyone loads, someone aims, someone fires. It's collective work. The gun kills, not individuals. Post-war analysis revealed the Zis-3's true strategic importance. Soviet victory required destroying German armour faster than German industry could replace it. Soviet artillery, particularly the Zis-3, achieved this at Kursk and maintained it through war's end. German tank production peaked at roughly 1,800 panzers monthly in 1944. Soviet anti-tank guns, dominated by Zis-3s, were destroying German armour faster than this production rate from Kursk onward. The economic comparison is even more striking. A Zis-3 cost approximately 12,000 rubles to manufacture. A German Panther tank cost roughly 117,000 Reichsmarks. Even accounting for exchange rate calculations and relative industrial capacity, the Soviets could produce anti-tank guns for perhaps 1/10 the cost of the tanks those guns destroyed. This cost differential, multiplied across millions of guns and shells, represented an economic advantage Germany could never overcome. After World War II, the Zis-3 remained in Soviet service and was exported extensively to Soviet allies and client states. The gun saw combat in Korea, where Chinese and North Korean forces used Zis-3s against American armour. Chinese Type 54 guns, direct copies of the Zis-3, were manufactured into the 1950s. The gun appeared in virtually every Cold War conflict where Soviet weapons were present, from the Middle East to Africa to Southeast Asia. The Arab-Israeli wars featured extensive Zis-3 use, with mixed results. In terrain allowing mobile operations, Israeli armour could outmaneuver the towed guns. In defensive positions or urban warfare, Zis-3s remained effective, particularly against lighter Israeli armoured vehicles. Egyptian and Syrian forces used Zis-3s through the 1973 Yom Kippur War, by which point the gun was clearly obsolete against modern armour, but still useful for infantry support. The Zis-3's extended service life, with some examples remaining in active service into the 1980s, testifies to the fundamental soundness of Grabin's design. A gun developed in 1941 remained militarily useful 4 decades later because its basic design was so robust and its manufacturing so straightforward that even nations with limited industrial capacity could maintain them. In 1985, the Soviet Union issued commemorative medals honouring World War II artillery designers. Vasily Grabin received his medal at age 85, one of the few weapons designers to see his creations not only succeed in combat but reshape an entire branch of military art. In his acceptance speech, he reflected on the Zis-3's development and impact. "We succeeded because we understood the crisis," he said. "Germany had better metallurgy, better optics, better engineering in many respects. But we had something more important. We had the ability to produce adequate weapons in overwhelming numbers. The Zis-3 wasn't the best anti-tank gun possible. It was the best anti-tank gun possible to manufacture in 1941 with available resources and workforce. That distinction mattered more than any ballistic calculation. Engineers who forget that production constraints are more absolute than physical laws create perfect weapons that exist only on paper." The Zis-3 existed in reality, over 100,000 of them, and that made all the difference. Modern military analysis of World War II increasingly recognizes that Soviet victory resulted from industrial advantage as much as military genius or heroic sacrifice. The Soviet Union could replace losses faster than Germany could inflict them. This advantage applied to artillery more than any other weapon category. Soviet gun production exceeded German and Western Allied production combined, and the Zis-3 represented the apotheosis of this quantitative superiority. But quantity alone doesn't explain the Zis-3's success. The gun also represented genuine engineering achievement. Grabin's team had created a weapon that was lighter, cheaper, and faster to produce than comparable designs, while maintaining equivalent or superior performance. This wasn't primitive engineering, it was sophisticated engineering focused on different priorities than German or American designers typically considered. The Zis-3's legacy extends beyond its service record. It demonstrated that weapons design must account for manufacturing reality, that simplified designs can equal or exceed complex ones in combat effectiveness, and that in total war, the weapon that exists matters more than the weapon that's theoretically perfect. These lessons influenced Soviet weapons development through the Cold War, with Soviet designers consistently prioritizing manufacturability and adequacy over technical perfection. The gun also influenced Western design philosophy, though less directly. American observation of Soviet artillery effectiveness led to increased emphasis on production engineering and weapons development. The post-war understanding that the Soviet Union had won partly through industrial might shaped American military-industrial planning during the Cold War, with emphasis on weapons that could be manufactured rapidly in wartime. Today, surviving Zis-3s can be found in museums worldwide. The Imperial War Museum in London displays a captured example alongside a German Pak-40, illustrating the different design philosophies. The Kubinka Tank Museum outside Moscow has an entire hall dedicated to Soviet artillery, with the Zis-3 prominently featured. The US Army Ordnance Museum at Aberdeen Proving Ground, before its closure and relocation, maintained several captured examples used for technical intelligence during and after the war. These museum pieces, carefully preserved and restored, convey little of the Zis-3's actual impact. They're clean, painted, displayed with informational placards listing specifications. They cannot convey the thunder of 8,000 Zis-3s opening fire simultaneously at Kursk. They cannot show the desperate crewman handling a gun into position while under fire. They cannot demonstrate the industrial achievement of producing 3,000 guns monthly while evacuating factories ahead of German advances. The story of the Zis-3 ultimately is a story about understanding what matters in total war. Vasily Grabin understood that Soviet survival required artillery that could be manufactured by tired women working 12-hour shifts in unheated factories using materials of uncertain quality. He designed for that reality, rather than for theoretical peacetime standards. The result was a gun that wasn't perfect, but was good enough and existed in numbers that made German victory impossible. German tankers feared Soviet artillery more than Soviet tanks. Allied observers noted Soviet artillery superiority, even while acknowledging German advantages in armour and tactics. The Red Army's artillery arm, equipped primarily with Zis-3s and similar designs, fired more shells than all other combatants combined. This dominance resulted from an industrial system that prioritised quantity without sacrificing basic quality, and from designers who understood that the perfect is the enemy of the good enough. Oberst Hans von Luck, commanding a panzer regiment through multiple Eastern Front campaigns, survived the war and in his memoirs provided perhaps the most telling assessment of Soviet artillery from the German perspective. "We feared their guns more than their tanks," he wrote. "A T-34 you could see, manoeuvre against, destroy with proper tactics. Their artillery was everywhere and nowhere. You couldn't see the guns. You only saw the result when shells arrived. Their 76mm guns, particularly that lightweight design they introduced in 1942, were mobile enough to reposition constantly, and numerous enough that destroying individual guns meant nothing. We killed their guns daily. More appeared the next day. By 1943, we understood we were fighting not an army but an industrial system. Their guns were products rolling off assembly lines faster than we could destroy them. You cannot win a war against an opponent who produces weapons faster than you can destroy them. Germany learned that lesson through the thunder of Soviet guns. The Zis-3 fired its last shots in anger during the Soviet war in Afghanistan, where Mujahideen fighters captured examples from Afghan government forces and turned them against Soviet forces in bitter irony. These final combat uses occurred nearly 50 years after the gun's design, a testament to its enduring utility and robust construction. In the final accounting, the Zis-3 represented more than a successful weapons system. It represented a philosophy of warfare that valued adequacy and quantity over perfection and scarcity. This philosophy, applied across Soviet weapons development, created an industrial military system that Germany could not defeat and that shaped Cold War military competition for decades. Vasily Grabin lived until 1980, long enough to see his gun become history. In his final interview, conducted months before his death, he was asked what he considered his greatest achievement. "Not the Zis-3 specifically," he replied. "The understanding that engineering serves production, and production serves victory. The Zis-3 embodied that understanding. It wasn't beautiful. It wasn't sophisticated. It was effective, manufacturable, and existed in the quantities necessary to win. In total war, that matters more than any specification." Over 103,000 Zis-3 guns built, over 1.5 billion shells fired, thousands of German tanks destroyed, tens of thousands of vehicles eliminate, uncountable fortifications reduced to rubble. Behind these statistics lie human stories, crews freezing in gun pits, factory workers collapsing from exhaustion, engineers calculating not just ballistics, but manufacturing hours and material costs. The Zis-3 was built by human effort, fired by human courage, and maintained by human endurance. The gun that began as an unauthorized project became the most produced artillery piece in history. The designer who risked execution for working without permission became a hero of socialist labor. The weapon that Soviet officers initially dismissed as inadequate became the backbone of Soviet artillery through victory and beyond. This transformation occurred because one engineer understood that in total war, the weapon that can be built fastest and deployed in greatest numbers will defeat weapons that are theoretically superior but practically scarce. The German officer who watched Zis-3s destroy his unit at Kursk, the Soviet crew that fired 200 rounds in an afternoon at Stalingrad, the factory worker who assembled barrels in an unheated plant at Gorky, all participated in the same industrial warfare equation. Production multiplied by distribution multiplied by employment equals combat power. The Zis-3 maximized every variable in that equation. Modern militaries still study the Zis-3, not for its ballistic characteristics, but for its design philosophy. How do you create weapons that can be manufactured rapidly using available industrial capacity and workforce? How do you balance performance requirements against production constraints? How do you design for adequacy rather than perfection? These questions, answered by Grabin and his team under the pressure of national survival, remain relevant whenever industrial capacity becomes a limiting factor in military effectiveness. The thunder of Zis-3 guns fell silent decades ago. The crews are gone, the factories converted to peacetime production, the battles relegated to history books. But the lessons remain. In total war, victory belongs not to armies with the best weapons, but to nations with the industrial capacity to produce adequate weapons in overwhelming quantities. The Zis-3 embodied that truth and fired over 1 billion shells proving it. Sergeant Mikhail Kuznetsov, who began this story freezing behind a gun pit outside Moscow, survived the war. In 1946 he returned to his village and resumed farming. His Zis-3, serial number unknown, was presumably scrapped or placed in storage. He never spoke much about the war, but in 1978, visiting Moscow and seeing a restored Zis-3 in a victory park, he stood before it for an hour. A bystander asked if he recognized the gun. "I fired one," he replied. 10,000 rounds perhaps, maybe more. That gun killed Germans. That gun brought me home. That gun won the war. It wasn't perfect, but it was ours, and there were so many of them the Germans drowned under the shells. That mattered more than anything else. The Zis-3 was not perfect. It was victorious. And in the calculus of total war, that's the only specification that matters. The technical specifications that made the Zis-3 revolutionary deserve deeper examination because they reveal how Grabin's team achieved the impossible balance between performance and manufacturability. The barrel assembly alone represented a masterwork of compromise engineering. Traditional artillery barrels were forged from solid chrome-molybdenum steel billets, then machined internally to create the rifling that spun projectiles for accuracy. This process required specialized boring equipment, precision measuring tools, and workers with years of experience. A single barrel might require 40 hours of machine time spread across multiple operations. Grabin's barrel used a fundamentally different approach. The tube was formed from high-quality steel, but instead of machining the entire length to tight tolerances, only critical areas received precision treatment. The chamber, where propellant combustion occurred and pressures peaked at over 2,800 atmospheres, was reinforced with a separate sleeve. The rifling lands and grooves were cut using a simplified broaching process that could be performed on standard equipment. The external diameter was left rough-turned rather than precision-finished, saving hours of machining time without affecting performance. The result was a barrel that weighed 42 kilograms, used 60% less steel than comparable designs, and could be manufactured in 12 hours by workers with minimal training. Artillery traditionalists predicted these barrels would fail catastrophically after a few hundred rounds. Testing proved them wrong. Zis-3 barrels routinely survived 8,000 to 10,000 rounds before requiring replacement, exceeding the service life of many conventional designs. The secret was understanding which tolerances actually mattered and which existed only because that's how barrels had always been made. The breech mechanism, the assembly that sealed the rear of the barrel during firing, received similar treatment. German artillery used complex interrupted screw breeches with dozens of precisely machined parts. These were elegant engineering solutions that required skilled machinists and careful assembly. Grabin specified a vertical sliding block breech with just 38 parts. The block dropped vertically into position, was locked by a simple cam mechanism, and extracted the spent cartridge case automatically when opened. A village blacksmith could understand the mechanism by watching it operate once. This simplicity had profound implications for training and maintenance. A gun crew could be taught to operate the Zis-3 in a single day. Clearing malfunctions required no special tools or knowledge. When parts broke, replacement took minutes. German forces capturing Zis-3s discovered they could put them into service immediately, without extensive training or technical manuals. This operational simplicity multiplied the gun's combat effectiveness, because it reduced the training pipeline and maintenance overhead that consumed resources in other artillery systems. The carriage design represented another triumph of practical engineering over theoretical perfection. Traditional artillery carriages used cast steel components because casting allowed complex shapes and concentrated strength where needed. But casting required specialized foundries, created long production delays while castings cooled, and resulted in components that were difficult to repair if damaged. Grabin's team designed the Zis-3 carriage entirely from welded steel plate and standard rolled sections. The trails, those long arms extending behind the gun that provided stability during firing, were fabricated from rectangular steel tubing rather than cast steel. The cradle that held the barrel was welded up from plate rather than cast as a single piece. The elevation and traverse mechanisms used commercial gearing and bearings available from automotive suppliers. Every component could be fabricated in any workshop with basic metalworking equipment. If a component was damaged in combat, field workshops could fabricate replacements without access to foundries or specialized tooling. This approach to carriage design reduced manufacturing time by over 50% compared to cast designs. It also created a carriage that was actually stronger in some respects than cast designs. Welded steel plate construction distributed stresses more evenly and could absorb battle damage that would shatter cast components. The Zis-3 could be knocked over by nearby explosions, dragged through rough terrain, and subjected to firing stresses that would break traditional carriages, then put back into service with minimal repair. The wheels demonstrated Grabin's understanding of Soviet logistics reality. Artillery wheels traditionally used specialized bearings, tires, and hubs designed specifically for guns. This meant maintaining separate supply chains for artillery-specific components. The Zis-3 used wheels adapted from Soviet truck designs with standard automotive bearings and pneumatic tires. Any Soviet maintenance unit could service Zis-3 wheels using truck parts. When tires were unavailable, the wheels could operate on bare rims, though this was hard on the wheels and reduced mobility. The shield, that curved steel plate protecting the gun crew, was perhaps the most visible manifestation of simplified design. Traditional gun shields used curved armor plate formed with expensive dies. The Zis-3 shield was fabricated from flat plates bent to shape and welded together. The armor thickness was 4.5 mm, enough to stop rifle bullets and shell fragments, but not heavy machine gun fire or artillery splinters. Soviet crews often supplemented the shield with sandbags or logs, creating improvised protection that was more effective than expensive armor plate. The sighting system balanced precision with simplicity. German artillery used sophisticated optical sights, with range estimation features and precision adjustments. The Zis-3's panoramic sight was simpler, but entirely adequate. Gunners could engage targets accurately at ranges up to 3,000 meters in direct fire mode using the sight's basic reticle. For indirect fire missions, a separate collimator sight allowed precise deflection settings. The sights could be manufactured in optical workshops without specialized equipment and were robust enough to survive rough handling that would destroy more delicate German sights. The complete weapon system weighed 1,116 kilograms in firing position, light enough that the six-man crew could manhandle it short distances. With the trails closed and wheels locked, the gun could be towed at speeds up to 60 km per hour by any vehicle from a jeep to a heavy truck. In emergency situations, horses could tow the gun, though this was slower and less efficient. The gun could transition from travelling configuration to firing position in under 2 minutes. A well-trained crew could accomplish this in 90 seconds. The firing sequence demonstrated the gun's operational simplicity. One crew member unlocked and spread the trails. 2 crew members attached the trails to ground stakes if time permitted. The gunner adjusted elevation and traversed a target. The loader inserted a round, the breech operator closed the breech, and the gunner fired. The spent cartridge case ejected automatically. The loader inserted the next round. Experienced crews achieved rates of fire approaching 25 rounds per minute, though sustained fire rates of 12 to 15 rounds per minute were more common to avoid overheating and crew fatigue. The ammunition itself deserves examination because Soviet doctrine emphasized a variety of shell types for different targets. The standard high explosive round, designated OF-350, weighed 6.2 kilograms and contained 760 grams of TNT equivalent. This shell was effective against infantry, light fortifications and soft targets out to maximum range of 13,290 meters. The shell's relatively small bursting charge compared to larger caliber weapons was compensated by the high rate of fire. A Zis-3 could put more explosive on target per minute than many heavier guns. The armor-piercing round, BR-350A, was specifically designed for anti-tank work. Weighing 6.5 kilograms, the solid steel projectile with a small explosive charge could penetrate 70 millimeters of armor at 500 meters when striking at perpendicular angles. Against sloped armor, penetration decreased significantly. This made the Zis-3 effective against all German tanks in service through 1942 and remained adequate against medium tanks through 1943. The introduction of Panthers and Tigers with heavier armor reduced the Zis-3's effectiveness in frontal engagements, but didn't eliminate it because Soviet gunners simply aimed for side and rear armor. The armor-piercing composite rigid round, BR-350B, used a harder steel core and achieved slightly better penetration, typically 75 mm at 500 meters. The armor-piercing capped round, BR-350BSP, had a ballistic cap that improved aerodynamic performance and a penetrating cap that helped defeat sloped armor, achieving roughly 80 mm penetration at 500 meters. Soviet ammunition factories produced millions of each type, giving gun crews flexibility to select ammunition based on expected targets. Specialized ammunition expanded the Zis-3's versatility. The O-350A high explosive fragmentation shell optimized fragmentation patterns against infantry in the open. The Sh-354T shrapnel round, a World War I era design that remained effective, scattered steel balls in a cone pattern useful against massed infantry. The D-350A smoke shell created screening smoke for obscuring friendly movements or marking targets. Even illumination rounds were available for night operations, though these were less common due to production priorities. The ammunition logistics were staggering. Each Zis-3 in frontline service required a continuous supply of hundreds of rounds monthly to sustain combat operations. During major offensives, ammunition expenditure could reach thousands of rounds per gun per month. Soviet logistics units maintained elaborate supply networks, moving ammunition from factories to storage depots to artillery units. The standardization on 76.2 mm caliber across multiple weapon systems simplified this logistics burden because the same ammunition trucks could supply divisional guns, anti-tank guns, and tank guns without specialized loading. Ammunition production facilities operated continuously throughout the war. The factories themselves represented triumphs of mass production. Assembly lines moved shell bodies through stations where they were filled with explosive, fitted with fuses and packed for shipment. Women workers, many of them teenagers, performed repetitive tasks with remarkable precision. Quality control was rigorous because defective ammunition could destroy guns and kill crews. Rejection rates were kept below 1% through constant inspection and worker training. The propellant charges were manufactured separately and assembled with shell bodies at loading plants. Soviet propellants used nitrocellulose formulations that produced consistent velocities across temperature ranges. Unlike some German propellants that degraded in extreme cold, Soviet charges remained reliable at temperatures down to -40 degrees Celsius. This reliability was essential on the Eastern Front, where winter temperatures regularly reached extremes that affected all equipment. The fuses, those small detonating mechanisms screwed into the nose of shells, were manufactured in dedicated facilities producing millions monthly. The standard impact fuse MD5 was remarkably simple and reliable. A spring-loaded firing pin was released when the shell hit the target, driving into a primer that initiated the explosive chain. The fuse could be set to function on impact or with slight delay, allowing the shell to penetrate light cover before detonating. More sophisticated proximity fuses, which detonated shells near targets without requiring direct hits, were developed late in the war but saw limited use due to production priorities. Training Soviet gun crews followed standardized procedures that emphasized speed over sophistication. Artillery schools operated throughout the Soviet rear, graduating crews after 4 to 6 weeks of intensive training. Instruction focused on practical skills: how to position the gun, how to load and fire, how to identify targets, how to work as a crew. Theoretical ballistics and advanced fire control techniques were reserved for officers. Enlisted crew members learned their specific jobs through repetition until actions became automatic. This training philosophy reflected Soviet understanding of wartime realities. Crews would be killed or wounded. Replacements needed to be trained quickly. The Zis-3's simplicity made this possible. A crew member killed during combat could be replaced by an infantryman with a few hours of instruction. This was impossible with more complex weapons requiring specialized knowledge. The Zis-3's operational simplicity thus contributed directly to Soviet ability to sustain artillery operations despite horrific casualties. Artillery officer training was more extensive, typically 6 months to a year at dedicated artillery academies. Officers learned fire control calculations, target identification, tactical employment, and command responsibilities. They studied previous battles, analyzed German tactics, and practiced with actual guns. The better Soviet artillery academies produced officers whose skills matched or exceeded their German counterparts. The less prestigious schools produced adequate officers who could employ their guns effectively if not brilliantly. The quality of Soviet artillery officers improved dramatically as the war progressed. Early war officers, many of them victims of Stalin's purges, or promoted beyond their competence, often employed artillery ineffectively. By 1943, Soviet artillery officers had absorbed hard lessons and developed doctrine that played to Soviet strengths. They concentrated fires to achieve overwhelming superiority at decisive points. They used massed artillery barrages to suppress German defences before assaults. They employed artillery and anti-tank roles with increasing sophistication as they learned German armour tactics. The role of women in Soviet artillery deserves special mention. Unlike other combatant nations, the Soviet Union employed women in direct combat roles, including artillery crews. Women served as gun commanders, loaders, and ammunition handlers. Some all-female artillery units achieved distinguished combat records. The most famous, the 1st Separate Women's Reserve Artillery Battalion, operated 122mm howitzers, but women served in Zis-3 units throughout the war. The presence of women in artillery reflected Soviet manpower crisis as much as ideology. By 1942, the Red Army needed every able body. Women could operate artillery as effectively as men, particularly when guns like the Zis-3 minimized physical strength requirements. The simplified mechanisms meant even relatively small women could load and fire the gun efficiently. Soviet propaganda celebrated women artillerists, though their service was primarily motivated by practical necessity rather than social progress. The tactical employment of Zis-3 units evolved throughout the war as Soviet doctrine adapted to German tactics and Soviet capabilities improved. Early war employment often wasted the Zis-3's potential through poor positioning, inadequate concealment, and uncoordinated fires. Gun batteries were positioned too far forward, where they were overrun by German advances, or too far back where they couldn't engage targets effectively. Fire missions were uncoordinated, with batteries firing independently rather than concentrating on key targets. By mid-war, Soviet artillery employment had matured significantly. Batteries were positioned in depth with primary and alternate positions. Concealment became standard practice with gun pits carefully camouflaged and approached by covered routes. Fire plans were coordinated at division and corps level, allowing massed fires to be delivered on key targets. Counter-battery operations targeted German artillery to achieve local fire superiority. The Zis-3's mobility was exploited through frequent position changes that prevented German counter-battery fire from destroying guns. The anti-tank ambush became a refined Soviet tactical art. Zis-3 batteries would establish positions covering likely German armour approaches, often in groups of 6 to 8 guns, creating overlapping fields of fire. The guns remained silent as German tanks approached, allowing them to close to point-blank range where even heavy German armour was vulnerable. On command, all guns would open fire simultaneously. The sudden volume of fire was devastating. German tanks caught in these ambushes rarely escaped. The psychological effect on surviving German crews was profound. Soviet doctrine emphasized artillery as the primary tank killer, not Soviet tanks. This reflected realistic assessment of Soviet armour quality versus German armour. Soviet tanks like the T-34 were excellent but faced operational and tactical disadvantages in direct engagements with German armour. Artillery faced no such disadvantages. A Zis-3 in a prepared position with clear fields of fire could destroy any German tank if the crew remained disciplined and aimed for vulnerable spots. Soviet tactical planning thus used tanks for exploitation and breakthrough, while relying on artillery for defensive anti-tank work. The integration of Zis-3 batteries with infantry units created combined arms teams that were increasingly effective as the war progressed. Infantry provided security for guns and identified targets. Guns provided direct fire support during assaults and anti-tank defense during German counterattacks. Communication between infantry and artillery improved from almost non-existent early in the war to quite effective by 1944. Radio sets became more common, allowing real-time fire missions. Forward observers learned to call fires accurately. Gun crews learned to respond quickly to fire missions without elaborate preparation. The use of Zis-3s in direct fire infantry support roles expanded as Soviet offensives gained momentum in 1944 and 1945. Guns were brought forward to engage bunkers, machine gun nests, and fortified buildings with direct fire. The high-explosive shell, while relatively small, was effective against these targets when fired at point-blank range. Gun crews became quite bold in bringing their weapons into forward positions, sometimes advancing with assault troops. This aggressive employment increased casualties among gun crews, but also increased infantry assault success rates. Urban combat presented special challenges and opportunities for Zis-3 employment. The gun's light weight allowed positioning in buildings where heavier artillery couldn't go. Crews would manhandle guns up staircases to upper floors, position them at windows with clear firing lanes, and use them to engage targets at close range. The Germans found these positions difficult to counter because they didn't expect artillery in buildings. The tactic was dangerous for gun crews because German return fire would bring buildings down on top of them, but it proved effective enough that Soviet forces continued using it through the battle for Berlin. The logistics of sustaining Zis-3 operations in combat were extraordinarily complex. Each gun required constant ammunition supply. A battery of 4 guns firing actively could expend thousands of rounds daily. This ammunition had to be transported from rear depots to firing positions over roads that were often impassable due to mud, snow, or battle damage. Soviet logistics troops, using trucks when available and horse carts when trucks weren't, maintained ammunition flow under conditions that would have paralyzed more sophisticated armies. Fuel for the trucks hauling ammunition was itself a major logistics challenge. The Soviet Union produced crude oil, but refining capacity was limited. Aviation fuel received priority. Artillery ammunition trucks often ran on low-grade fuel that caused engine problems. Soviet truck drivers and mechanics kept vehicles running through improvisation and determination. When fuel ran out completely, horse-drawn transport continued the ammunition flow, though at reduced rates. The ability to continue artillery operations despite logistics breakdowns was a Soviet strength that German forces never matched. Maintenance of Zis-3s in field conditions demonstrated the value of simplified design. Guns operated continuously in conditions that would have disabled complex weapons. Mud, snow, rain, dust all affected operations. The Zis-3's simple mechanisms kept functioning when German guns seized up. When repairs were necessary, Soviet crews often improvised solutions. Broken parts were fabricated in field workshops. Damaged components were straightened and reused. Guns that would have been written off in other armies continued firing in Soviet service. The arrival of the Zis-3 in Soviet service coincided with improvements in Soviet artillery fire control and coordination. Early war Soviet artillery operated with minimal fire control, essentially pointing guns at targets and firing until they ran out of ammunition or the target was destroyed. By mid-war, Soviet artillery had adopted systematic fire control procedures using forward observers, pre-planned fire missions, and coordinated batteries. The Zis-3's relatively long range for its size and its accuracy made it effective in these coordinated fire plans. Soviet artillery doctrine emphasized massed fires delivered on narrow frontages to achieve overwhelming local superiority. During major offensives, Soviet forces would concentrate hundreds or thousands of guns in sectors just a few kilometers wide. The resulting artillery bombardments were apocalyptic in scale. German defenders described the ground shaking continuously for hours, visibility reduced to nothing by dust and smoke, communications destroyed, casualties mounting even in deep bunkers. The Zis-3 contributed to these bombardments alongside heavier guns, its high rate of fire compensating for its relatively small shell weight. The Battle of Berlin in April and May 1945 saw Zis-3 employment on a scale that defied comprehension. Soviet forces attacking the city deployed over 12,000 artillery pieces, including thousands of Zis-3s. The guns were used for everything from counter-battery fire to direct assault support. Gun crews brought their weapons into the city streets, engaging targets at ranges measured in meters rather than kilometers. The Zis-3's simplicity and reliability proved invaluable in this environment, where complex weapons failed due to dust, debris, and battle damage. German defenders of Berlin, many of them hastily trained Volkssturm militia and Hitler Youth, faced Soviet artillery with inadequate protection and no effective counter. The volume of fire Soviet guns delivered was simply overwhelming. German positions were obliterated before defenders could react. German counter-battery fire was sporadic and ineffective. By the final days of the battle, Soviet artillery operated with near impunity, destroying any target that revealed itself. The Zis-3's contribution to this final Soviet offensive demonstrated how completely Soviet artillery had achieved dominance. The human experience of serving in Zis-3 crews deserves consideration beyond tactical and technical analysis. Gun crews lived under conditions of extraordinary hardship. They slept in muddy gun pits or freezing bunkers. They ate irregular meals of poor quality. They existed under constant threat of German artillery, aircraft, and counterattacks. Many crews were killed in their gun pits, cut down by German fire before they could escape. The casualty rates among Soviet artillery crews were horrific, particularly in the first years of the war when German tactical superiority allowed them to systematically destroy Soviet gun positions. Despite these conditions, Soviet gun crews maintained their weapons and fought effectively. The psychological burden was immense. Gun crews watched friends killed beside them. They saw infantry advance through fields they had just fired across, walking among corpses their shells had created. They fired thousands of rounds at targets they often couldn't see, trusting that someone upstream in the command chain had identified legitimate military objectives. The moral weight of artillery service, the knowledge that your actions killed people you never saw, affected some crews profoundly, while others became numb to it through necessity. The relationship between gun crews and their weapons often became personal. Crews named their guns, painted kill markings, decorated them with slogans and insignia. A gun that had survived multiple battles with its crew intact was considered lucky. Superstitions developed around gun number assignments and firing procedures. These behaviours, common among artillerists in all armies, helped crews cope with the stress of constant combat. The gun became a familiar constant in an environment where everything else changed unpredictably. The post-war fate of the Zis-3 reflected its utility and the practical needs of the Soviet Union and its allies. Production continued into the early 1950s, even though more modern anti-tank weapons were available. The gun remained in Soviet service through the 1950s, in progressively less critical roles as more modern weapons replaced it. Export to Soviet client states continued through the 1960s, with thousands of Zis-3s shipped to nations across Asia, Africa, and Latin America. Many of these guns saw combat decades after World War II ended, fighting in conflicts that had no connection to the circumstances that created them. The final combat use of Zis-3s occurred in regional conflicts as late as the 1990s. Afghan government forces used Zis-3s during their civil war. African conflicts saw Zis-3s deployed by various factions. These late uses demonstrated the gun's extraordinary longevity but also its obsolescence. Against modern armour and with crews lacking proper training, The Zis-3 was ineffective. Its continued use reflected availability rather than capability. Nations with limited resources used whatever weapons they possessed, even 50-year-old artillery pieces designed for a different kind of war. The Zis-3's influence on post-war Soviet weapons development was profound. The design philosophy Grabin pioneered, emphasizing manufacturability and adequacy over performance maximization, became standard in Soviet military-industrial practice. Post-war Soviet weapons like the AK-47 rifle, the RPG-7 grenade launcher, and the T-55 tank all reflected this philosophy. They were simple, robust, adequate in performance, and manufacturable in enormous quantities. This approach served Soviet military interests well throughout the Cold War, and continues to influence Russian weapons design today. Western observers studying Soviet weapons often misinterpreted this design philosophy as technological backwardness. Soviet weapons looked crude compared to Western equivalents. They lacked sophisticated features, used cheaper materials, and had looser tolerances. Western analysis often concluded that Soviet industry simply couldn't build weapons to Western standards. This missed the point entirely. Soviet designers could build sophisticated weapons when necessary. They chose not to because sophisticated weapons couldn't be produced in the quantities Soviet doctrine required. The Zis-3 provided the template for this approach. It demonstrated that a weapon designed for mass production could match or exceed more sophisticated designs in actual combat effectiveness. The gun's success validated Grabin's conviction that in total war, quantity has a quality all its own. This lesson shaped Soviet military thinking for generations. Soviet planners assumed future wars would be total wars requiring mass mobilization of industry. Weapons had to be designed for this contingency, rather than for peacetime parade ground perfection. Modern military historians studying World War II increasingly recognize artillery as the dominant killer on the Eastern Front. Estimates suggest artillery caused 60 to 70% of all casualties in the theatre. The Zis-3, as the most numerous Soviet artillery piece, contributed disproportionately to this total. While German tanks receive extensive historical attention and German tactical excellence is widely acknowledged, the reality is that most German casualties on the Eastern Front were inflicted by Soviet artillery, firing high explosive shells at infantry and soft targets. The Zis-3's high explosive round, repeated hundreds of thousands of times across thousands of kilometers of front line, killed more Germans than all Soviet tanks combined. This grim arithmetic of industrial warfare is often overlooked in favor of more dramatic narratives about tank battles and infantry heroics. Artillery is inherently less dramatic. Crews fire at targets they can't see. Shells land on people who never know what hit them. There are no exciting maneuvers, no individual heroics that translate well to storytelling. But artillery won the Eastern Front by making German positions untenable and German movements suicidal. The Zis-3's contribution to this achievement justifies its historical significance beyond its impressive production numbers. The economics of Zis-3 production reveal how Soviet industrial mobilization achieved results that seemed impossible. The Soviet Union entered the war with less industrial capacity than Germany. Soviet factories were less efficient, workers less skilled, materials less abundant. Yet Soviet industry outproduced German industry in every major weapons category by 1943. This achievement resulted from ruthless prioritization, brutal working conditions, and designs like the Zis-3 that maximized output per unit of input. The human cost of this production miracle was staggering. Factory workers, predominantly women, children, and men unfit for military service, worked 12 to 16-hour shifts 6 or 7 days weekly. Rations were inadequate, heating insufficient, medical care minimal. Workers collapsed from exhaustion, malnutrition, and disease. Production tempo never slowed. The alternative was German victory, which meant death for most Soviet citizens. This existential threat motivated superhuman efforts. Workers who might have rebelled against such conditions in peacetime accepted them as necessary for survival. The Zis-3 production lines at Factory 92 and other plants operated continuously throughout the war. Components moved along conveyors where workers performed single operations repeatedly. One worker might weld the same joint on hundreds of carriages per shift. Another might install the same component on dozens of breech mechanisms. This extreme division of labour, borrowed from automotive mass production, allowed rapid training and high output rates. Workers became extraordinarily efficient at their specific tasks, even though few understood the complete weapon. Quality control was maintained through inspection stations positioned throughout the assembly process. Inspectors, often older skilled workers or wounded veterans, checked components and sub-assemblies for defects. Rejected items were diverted for rework or scrapping. Despite the speed of production, quality remained high because Grabin's design incorporated inspection-friendly features. Critical dimensions were easy to check. Functional tests could be performed quickly. The simplicity of the design meant there were fewer things to go wrong, and they were obvious when they did. The final test of each completed Zis-3 was proof firing. The gun was loaded with an overcharged cartridge producing higher than normal pressures and fired several times. This test verified that the barrel, breech and carriage could withstand firing stresses without failure. Guns that passed proof testing were marked with acceptance stamps and shipped to military depots. The proof testing was not merely bureaucratic compliance. It ensured that guns reaching frontline units would function reliably under combat conditions. The low failure rate of Zis-3s in service validated the testing protocol. Transport of completed guns from factories to frontline units involved the Soviet rail network operating under wartime stress. Trains carrying guns, ammunition and supplies moved continuously eastward, while trains carrying troops and evacuated civilians moved westward. The Soviet rail system, running primarily on broad-gauge track incompatible with European railroads, was relatively secure from German interference beyond air attack. Trains were dispersed, camouflaged, and operated primarily at night to reduce vulnerability. Despite German efforts, Soviet rail transport maintained weapons flow to combat units throughout the war. The distribution system allocated guns based on unit priority and operational needs. Guards units received priority for new equipment. Units in active combat received replacement guns before units in quiet sectors. This allocation system ensured that guns went where they were most needed, though it created resentment among units receiving older equipment. Commanders sometimes traded favors, food, or captured items to obtain better weapons for their units outside official channels. This informal logistics network operated parallel to the official system, ensuring units had what they needed to fight effectively. Vasily Grabin's personal story after the war reflected both his achievements and the Soviet system's ambivalence toward individual genius. He received honors including Hero of Socialist Labor and multiple orders. He continued working in weapons design through the 1950s, but he was never given the autonomy he had exercised during the war. Soviet bureaucracy, which he had bypassed to create the Zis-3, reasserted control over weapons development. Post-war Soviet weapons design became more committee-driven, more bureaucratic, less innovative. Grabin chafed under this system but lacked the authority to change it. In interviews late in life, Grabin expressed satisfaction with the Zis-3 while acknowledging its limitations. He noted that the gun's success resulted from specific wartime circumstances that forced radical approaches. He doubted similar innovation would be possible in peacetime when institutional inertia and bureaucratic caution dominated. He expressed frustration that his design philosophy, validated by the Zis-3's success, hadn't transformed Soviet weapons development permanently. The lessons were learned during the war, then forgotten in the decades that followed. The Zis-3's story concludes not with dramatic final battles but with gradual obsolescence and retirement. As the Soviet Union modernized its military in the 1950s and 1960s, the Zis-3 was progressively relegated to training units, reserve stocks, and export to allies. Thousands were scrapped, their steel recycled into other uses. Thousands more sat in warehouses, forgotten relics of a war that seemed increasingly distant. A few hundred were preserved in museums or as memorials, cleaned and painted to represent weapons that had been dirty, worn, and used hard. These memorial guns, standing silent in parks and museums, cannot convey the thunder of thousands firing simultaneously. They cannot show the crews who served them under conditions of unimaginable hardship. They cannot demonstrate the industrial achievement they represented or the tactical impact they delivered. They are objects now, artifacts of history, studied by people who never heard their distinctive crack or smelled the bitter smoke of propellant. Yet the Zis-3's legacy extends beyond these silent memorials. The gun demonstrated principles that remain valid in military planning. that weapons must be designed for production realities, not theoretical ideals, that adequacy at scale defeats perfection in scarcity, that industrial capacity is itself a weapon that can be decisive, that engineering genius sometimes means knowing what not to build rather than building the absolute best. These lessons, learned through the crisis of total war, remain relevant whenever military forces confront the gap between what they want and what they can actually have. The Zis-3 was never the best anti-tank gun of World War II by any single measure. It wasn't the most accurate, didn't have the longest range, didn't penetrate the most armour, wasn't the fastest to deploy. But it existed in quantities that made German victory impossible. It could be manufactured when other weapons couldn't. It could be operated when other weapons failed. It could be maintained when other weapons required depot repair. It fired billions of rounds that killed tens of thousands of Germans and destroyed thousands of German vehicles. It was good enough, and there were enough of them, and that combination won battles, campaigns, and ultimately the war. In the calculus of total war, the Zis-3 represented the wisdom of adequacy over the folly of perfection. Vasily Grabin understood this in 1941 when he began his unauthorized design work. The Red Army understood it by 1943 when they had enough guns to matter. German forces understood it too late to counter it. The thunder of 100,000 Zis-3s firing 1.5 billion rounds told a story about industrial warfare that no tactical brilliance could answer. The gun that Soviet officers initially dismissed won the artillery war on the Eastern Front through the simple mathematics of production, multiplied by employment. That remains its enduring legacy and the final judgment of its historical significance.